Iron is a very important metallic element that has been known and used by humans for a very long time. In the periodic table, it is located in the D block. It has an atomic number of 26 and a relative atomic mass of 55.8. In this lesson, you will learn about the occurrence of iron and the method employed in its extraction from its ore. Iron is abundant on Earth. In fact, among the metals found in the Earth's crust, iron is the second in abundance after aluminium. It also constitutes about 35% of the Earth as a whole. Like most metals, iron is found in its combined state and not in its free metallic state. Naturally, it is found combined with other elements in different ores, such as magnetite, hematite, siderite, and iron pyrite. Iron ore can be found in different parts of the world, including African countries such as Algeria, Morocco, Nigeria, South Africa, and Zimbabwe. Iron can also be found in the human body. Approximately, the average human body is made up of about 0.004% of iron, which is equivalent to about 4.5 grams. 65% of the iron can be found in the hemoglobin, which is a protein in the blood. Now let's discuss how iron is extracted from its ore. Like other metal extraction processes, iron ores need to undergo a preliminary stage which involves roasting. This is done to remove traces of water in the ore, and also to convert sulfides or carbonates which may be present in the ore to iron 3 oxide. Once the iron ore is roasted, it is added together with coke and limestone, which is calcium trioxocarbonate 4, into a blast furnace. In the furnace, the mixture is heated to a high temperature of about 1,800 degrees Celsius from the bottom by blowing in a hot stream of air. The furnace temperature varies from about 1,800 degrees Celsius at the bottom to about 200 degrees Celsius at the top. At the lower part of the furnace, the limestone decomposes to form calcium oxide and carbon 4 oxide, while the red-hot coke is oxidized to carbon 4 oxide. As the carbon 4 oxide produced at the bottom rises to the middle, it reacts with hot coke at the middle of the furnace. Here, the coke reduces carbon 4 oxide to carbon 2 oxide, which in turn is used to reduce iron 3 oxide to iron towards the top of the furnace, as shown in the chemical equation here. The basic concept of iron extraction is to remove oxygen from iron 3 oxide. This is achieved during the reduction reaction, in which carbon 2 oxide removes oxygen from iron 3 oxide to form molten iron, which settles at the bottom of the furnace. The calcium oxide produced during the decomposition of limestone helps to remove silicon 4 oxide, which is an impurity removed in the form of calcium trioxosilicate 4. The calcium trioxosilicate 4 and other impurities present in the ore also settle at the bottom of the furnace as molten slag, where it floats on top of the molten iron. Both the molten slag and iron can then be tapped off separately. To help you remember the key points from this lesson, here's a quick recap. Iron is the second most abundant metal in the Earth's crust. Naturally, it is found combined with other elements in different ores such as magnetite, hematite, siderite, and iron pyrite. Iron is extracted from its ore through a thermal reduction process. Iron ore, coke, and limestone are raw materials used for the extraction of iron in a blast furnace. I hope you enjoyed this lesson, and I'd love to see you again in the next one.